Hello everyone, welcome back to my YouTube channel. So in this video, I'm going to start with a control system engineering subject series. So this is as per the video syllabus for electrical and electronics engineering students, as well as the same concepts which will be there in our electronics and communication engineering students. So it will definitely help you. If you are having any doubts regarding this, anyhow, you can feel free to write in the comment box. So now I'm considering the triple E stream VTU syllabus for sixth semester as well as fifth semester engineering students. So totally five modules are there. Module 1, 2, 3, 4. You can see here. Mm, Module 1, Introduction to Control Systems. And here we'll be having the introduction and classification of control systems, as well as a very simple and enjoying parties mathematical models of physical systems, modeling of mechanical system elements, which includes translational system and rotational system. We'll get to know whenever the concept which will come. So also it has electrical systems, analogous systems, transfer functions, single input, single output systems, and the procedure for deriving transfer functions, servo motors, as well as gate range. Similarly, the module 2 is also kind of enjoying module A, that is block diagram and signal flow graph. So module 3, which includes time domain analysis, Roth stability criterion, and module 4, which includes root locus, frequency domain analysis, Bode plots, and module 5, which has control systems, compensators, and controllers, and also we'll be having the state space model. So model 5 is easy. We'll get to know. You can see the question paper pattern, textbooks, reference books. Anand Kumar textbook is well and good. So without wasting time, let me start with module 1 now. So it has an introduction to control systems, and it includes a control system introduction and classification of control systems. And also in the second chapter, we'll be having the mathematical models of physical systems, which includes mechanical element systems, electrical systems, analogous systems, and also the transfer functions, single input, single output system, procedure for deriving transfer functions, servo motors, and gate trains. You can easily target 20 out of 20 in external examination for both ECE and electrical students. Without wasting time now, so you can see the introduction part. So first thing you should know what is system. You can easily compare with a practical life as well as system society. A system, it is a collection of objects or components connected together to serve an objectives. It's a collection of a community. Each community is having its own objective. So like that you can compare, so that it's a collection of objects or components, and you need to connect it together to serve an objective. Every system is has its own objectives. For example, the objective of institute is to give engineers to the society, like that control system. So you need to control that object. That is nothing but any quantity of interest in a machine or other equipment is maintained in accordance with desired manner. Means we need to control a system. So any quantity of interest in a machine, instead of community can consider electrical equipments like machines or other equipments. You need to maintain that electrical machines. You need to maintain that electrical equipments with a desired manner. That maintenance is nothing but a controlling, or else you can say it is a system in which the output quantity is controlled by varying the input quantity. For example, a teacher is controlling a classroom, students. The community of the student is nothing but a system. We are controlling the system in the classroom. We, the teachers. So that teacher is controlling a classroom. That system we can call that as a control system. We are controlling the class. Okay, so that any control system which is consisting of three essential components, namely you can say input system and output system. Okay, and input and system and output. Input, whatever the work we are assigning to a student is input. The submission date of the assignment, we can call that as output. In between, whatever they are writing in assignment textbook, that is what we can call it as a system. Easily you can understand. So that the input is the excitation applied to a system from an external energy source to a particular equipment. A system is nothing but it is a it is the arrangement of physical components. You are giving input to the system. System is having the physical arrangement of the systems, physical arrangement of the components. And once after applying the input to the system, it will give you response. That response you can call that as output. So that output is the actual response obtained from the system. So you can see the control system may be one of the following type. Either it may be man-made, or it may be natural or biological, or else hybrid, integrating both man-made and natural. That is nothing but man-made and natural or biological, that we can call it as a hybrid. Okay. So can see for the examples of control system, it's all basic examples you can see in daily life. An electric switch is a man-made control system controlling the flow of electricity. If you switch on the button, the lamp becomes on or fan becomes on, whatever the equipment that becomes on, which means that we are giving input to the switch by pressing that. That is nothing but flipping the switch on or off is the input. System is electric switch. So once if you switch on the switch, then the flow of current, the flow of charge which will be happen from input, that is a switch to the electrical equipments, and it completes the path. That is nothing but due to that flow of charge, due to that flow of current, the lamp becomes on, the electrical equipments become on. That is we can call it as output. Input is a button, system is a lamp. If we click on the input, lamp becomes on. The brightness of the light, or if the lamp is on, that is output. So that an electrical switch is man-made control system controlling the flow of electricity by switching on and switching off. And second one is pointing a finger at an objective, or else an object is called as biological control system. You can see the example: input, system, output. You are giving the direction of the object with respect to the some direction. For example, straight or left or right or backside. That is the input, straight. System. So if I am giving a sight, means the eyes, it consists of eyes, arm, hand, finger, brain of the man, everything I am giving. So this is whatever I am showing, that is pointing finger, moving the arm, eye movement, brain thinking level. That is what the man is considering a system. The output is actual pointed direction, straight or left or right or backward with respect to the same direction. Okay. And hybrid means nothing but you are driving a vehicle. Suppose if you are driving a car, you need to use a car, and with the help of your hands, you can move the steerings, we can change the direction of the vehicle that is moving. You are controlling the car. That is nothing but a man driving an automobile is a hybrid system. For that, you can see input is direction or lane. Either the car should move straight or left or right or reverse. And system is nothing but driver's hand, eyes, brain, vehicle. And output is heading of the automobile. That moving of the vehicle is nothing but output. If you are pressing on the acceleration, vehicle that will move. Very simple examples. So with respect of that, you need to know a few things. Physical system. So once after collecting the physical objects, you need to connect together to serve an objective is called as a physical system. Physical model. An idealized physical system is called a physical model. Mathematical model. Mathematical representation of the physical model through the use of appropriate physical laws. Either can you use Faraday's law of electromagnetics or Newton's law, whatever can use. You can call this mathematical model. It is a linear system or is a linear model. Coming back to this classification of control system, you can see that depending on the hierarchy, you can see the open loop control systems, closed loop control systems, optimal control systems, adaptive learning. This is all depending on hierarchy. We'll discuss this one by one later, open loop, closed loop, and all in the next video. And again, the depending on the presence of human being as a part of control system, manually controlled and automatic control. Depending on the presence of feedback, open loop, closed loop, we'll discuss that in a next video. According to the main purpose of the system, position control system, velocity control system, process control system, temperature control systems, traffic control systems. Suppose if we are having the feedback control system, feedback means nothing but the controlling path. So here also feedback control systems classified according to the different parameters. That is, the first one is a method of analysis and design. Based on that, you can classify it as a linear control systems, non-linear control systems. Again, we will discuss about this in the next video. And we are having whether the parameters of the system remain constant or vary with the time, with the help of that time varying control systems, time invariant control systems, and the types of signals used in a system with the help of that continuous data control system and discrete data control systems, AC control systems and DC control systems based on the applications with position control system, velocity, process, traffic control systems. In general, traffic control system means you are controlling the traffic with the help of red, yellow, green. Okay. And based on the number of inputs and output, it is having a single input, single output control systems and multi-input, multi-output control systems based on the number of open loop poles present at the origin of the spline. Type 0, 1, 2, 3 at a will be having the types. And based on the according to the order of differential equation, again the first order differential equation system and the second order control system, depending on the dampings, undamped systems, underdamped system, critically damped system, overdamped system. Okay. So this is all about the just a classification of control system. We'll discuss detailed classification in next video. So if you really like this video, kindly do subscribe and share maximum. Have a nice day and wait for the next video. I'll upload soon. So the control system series will start and it begins. Uh, Feel free to write in a comment box if you're having any doubts. Thank you and have a nice day.